G'day viewers. In this segment I'll give you an introduction to the domain name system. So our topic for this lecture and for the next lecture is the domain name system, the DNS, as you might have heard it called. The DNS is responsible for mapping between host names, these nice human readable names for computers, and their IP addresses, as well as other associated functions. In this first segment I'm going to give an introduction to the concepts of the DNS and focus on the namespace itself and naming different hosts. So let's start with just the idea of names and addresses. Names here are really high-level identifiers for different resources, whereas addresses are these lower layer identifiers which provide typically a way of locating a resource. Now, really there are multiple levels of addressing and naming that can go all the way down to the bottom here, starting from the high level to the low level. For instance, a full name might be a high level name which might be mapped to a lower level address such as an email address. But this email address itself could also be thought of as a high level name which could be mapped to a lower level address such as an IP address and then an Ethernet address to find it. Resolution or lookup is the process of mapping a name to its address. So if all of this sounds a little formal, you might really think of it as just being like a phone book, in the sense that is a directory and you use it to look up a name to addressing information about it. In a phone book you might take a name like Andy Tannenbaum to an address where you'll be able to contact him. In the DNS we'll more typically take a host name written like this, flits.cs.vu.nl, to an IP address such as an IPv4 address here. Now before the DNS, in the early ARPANET, the way that we mapped from host names to IP addresses was just with a file called host.txt. You just needed a copy of that file. So it was regularly retrieved by sites from a central location at what was called the NIC. Here NIC stands for Network Information Center, not your network interface card. The NIC was, just the body in charge of the network, so you would copy an authoritative version of this file from the NIC and distribute it to all the machines. Names in this space were initially flat, just the name of your computer, Galar, Vegemite, whatever you'd like. But they became hierarchical, such as lcs.mit.edu, starting in about the mid-80s. As you might imagine, this first initial scheme, copying the authoritative file from the central information repository, was neither very manageable nor very efficient as the ARPANET grew into the internet. It wasn't very manageable because there's one central location and you need to coordinate with it to get your information into the network, and there are possible naming conflicts, especially when everything's flat and so forth. It's not very efficient because there's a bit of a delay getting that information there and before everyone's copied down the file nightly so they can contact you. And it's also not very efficient simply because that whole file has been transferred repeatedly to everywhere on the internet, whether everyone needs to contact everyone else or not. So the idea of the DNS, which emerged, actually I'm not quite sure when, the mid-80s, I would guess gradually. The idea with the DNS is to provide an automated system that performed this mapping between the host names and the IP addresses without this central repository that everyone had to coordinate with. So we still want to be able to perform this same translation as though we were looking up a local file, but we're not going to have the local file anymore. I haven't told you exactly how we're going to do it yet because we're going to get to a lot of that later in the second part. Now we're just going to go through the namespace. I'll say here that the goals, really just at a high level, they're to make the administration of names easy to manage, especially amongst all of the different multiple parties that are involved in the internet. Having to get these parties to coordinate and agree on naming conflicts would be a pretty big job, so we would really like to come up with a system that makes it easy to manage administration of names, even when multiple parties are involved. We'd also like the domain name system to be efficient. Here efficient means a few different things. It means good performance so that we can map quickly between host names and IP addresses. This is necessary because the first time you contact a site, for instance, you'll need to work out its IP address to contact the server and retrieve a page from that site. So any latency here is contributing to latency as you surf the web. It's adding to page load times. We'd also like the DNS to be fairly lightweight in that you require few resources or few hosts to be able to run it, so it's efficient in that sense. Well, the approach that we're going to get to eventually is to use a distributed directory service, or at least that's what we're going to design and implement, a distributed directory service. It's going to be based on a hierarchical namespace, such as the lcs.mit.edu, because that's going to provide a natural way to break up the namespace and distribute it to different hosts. And to tie all the pieces together when everyone has a different portion of the namespace, we're going to use an automated protocol. That's the DNS protocol. So just maybe to step back and emphasize the difference between a host.txt file approach and this approach that we're moving towards. In host.txt, you had a copy of the entire internet namespace in your computer to use. With the DNS, there is no one large file with all of the internet namespace. It's distributed. So you just use a protocol, the DNS, to access the portion of it that you need at a particular time. Well, I'm getting ahead of myself. So let's just begin from the beginning and talk about the DNS namespace. This is what the namespace looks like. It's hierarchical, so that means it's an upside down tree if you like. Here's the root, it's this dot, it's called dot, although we typically omit the dot when we write names, as you'll see in a minute. So there are many branches out from this root. I'll just highlight one here, the one that goes to the edu domain. All of these top ones, this first layer, are what are called the top level domains. That's this row here, such as edu. And after edu, again, since it's a tree, from these top level domains we divide and have other names there. Under edu here I've just shown one particular name, Washington. Washington.edu, the University of Washington. But there'll be many other branches of .edu, one for MIT, one for Berkeley, Stanford, and so forth, all of the other universities. And we can continue this for as many different layers as we'd like. Under Washington.edu, the namespace here just happens to be distributed into a couple of branches shown here. One for the CS, that's the Computer Science Department, another one for Eng, the School of Engineering, and there would be many other different branches in any university, of course. And within CS, I've just shown one branch here for a particular computer called Robot. The reason I've highlighted some of these branches is just to get down to the end, so there'll be all sorts of other ones off the tree here. But for the path at the end, we would write this host name. This would be robot.cs.washington.edu. That should look like a familiar host name to you, not the particular name of it, but just the, let me make that a little clearer, just the particular form of names. So you'll note that the name there is, we gain it by going up the tree towards the root, from the leaf back to the root, of course. And you'll also note that, the dot, logically there is a dot at the end here, that's the very end. Usually we can omit this as common convention. Well, so let's talk about the namespace a little more. So there are, I'll just tell you about some of the top level domains. That's sort of where a lot of the action is in terms of some of the interesting news articles you'd read. Now, this tree, the domain namespace, is administered by a body called ICANN, the Internet Corporation for Assigned Names and Numbers. ICANN was formed in about 1998. And it really came into existence as the internet grew because there was a lot of attention around matters such as naming. Naming, it turns out, is a very financial, political, and international topic. Everyone gets very involved in it. And particularly as the internet began to transition from an American institution, an American administered institution, to a worldwide international asset, some of the administration became a little more general with ICANN serving as the body. So ICANN here began to administer the top-level domains, or TLDs as they're called. Initially, when the internet was young, from the beginning of the DNS, there were 6 TLDs. Well, pretty close to the beginning anyhow. .com, .edu, .gov, .mil, .org, and .net. You're probably familiar with most of these already. In fact, most of the TLDs that you might see Although I would remind you actually that since ICANN took over, there has been a process for adding more TLDs. And in fact, a series of other TLDs, we must have around 14 or so, have been added, starting from about 2001. With TLDs such as .aero for the aerospace industry, .museum and so forth. These are little used compared to some of the other ones, but who knows where they'll end up ahead of time. The most recent addition to get us to the 22 was .xxx for the sex industry in 2011. And as you might imagine, this was a little political. It took, or controversial. It took years to come into being. And now that it exists, we'll see if it gets used. Many of these different top-level domains have different usage policies. These 22 ones I'm talking about are what's called the generic TLDs. Generic just means that they describe a whole category, and the usage policy is going to depend on the category, what it was intended for and how it's administered. For .com, for instance, well, it's really for companies or commercial institutions, but anyone can get a .com address. You just have to pay your $10 or whatever it is to a registrar to serve the name. On the other hand, other top-level domains like .edu are for approved educational institutions, and presumably not anybody can get a .edu address. As well as these generic top-level domains, there is also a much larger list of country code domains. There are around a couple of hundred of these, or 250 or so. These are two-letter country codes which come from a standard list of countries. This is not invented by the internet. It's more administered by the ISO, so by international bodies. So these two-letter country code, they might be familiar to you. They're things like AU for Australia and so forth. And recently, starting in 2010, these country code can also be written using internationalized scripts, Chinese characters, Arabic characters, and so forth. Now, while these TLDs were really intended for country usage, this is why everything in the UK ends with UK, for instance, or in Spain, ES. Many of these country codes have been widely commercialized. For instance, Tuvalu is a small island. They happen to have .tv. So they've sold the rights for .tv and they partner, I think it's with VeriSign. Because of course .tv is a domain name that many TV stations might like to acquire. And actually this island makes a small amount of money over it. They would like to make more money over it. There's actually a little bit of controversy over it. But they get a feed of money from the naming of .tv. Another one you might have heard of is .fm for radio stations. These are the Federated Islands of Micronesia, I believe, something like that. You might have also seen quite recently there's been a flurry of domain hacks. For instance, Instagram with the .am. This is really the .am being a country code, Armenia, but been reused as a way to spell Instagram just with fewer letters than beginning in a .com. Similarly for Google, goo.gl. The GL stands for Greenland and so forth. So as you've just seen from surfing the web, these country codes are really beginning to be exploited in all sorts of ways. And presumably some money for their licensing flows back to the country itself. Okay, so we've talked about the DNS namespace. That's this tree. We haven't yet gotten to how we would divide this up for distribution. So I want to get to that because that's the heart of really how the DNS operates. This namespace is divided up into zones, and a zone is simply a contiguous portion of the namespace. It's the portion of the namespace we're going to serve with a DNS server. So for instance, a zone could be this. This is like everything under the acm.org domain. Even though there are subdomains there, one zone contains all of that information. We'll put that all together in some file that can be accessed. Here's another example. In Washington, just for the picture here, we might have everything under Washington and the Washington domain and the eng.washington.edu domain, but not the cs.washington.edu domain, which would be handled by someone else. So what this really means is that CS has been delegated from Washington to a different zone, and CS is in this zone, with the robot. And really this would be because the computer science department administers its own zone and serves its own zone from its own server. So these zones, right now they're just a different way, they're a way of dividing up this namespace into pieces. And I've just circled a few to show you the different kinds of pieces that might exist. Edu is a zone too. So what that zone will know is anything in there which is really just the links to the other zones. So there are links between all of these pieces. One zone, if there's something low, will have a pointer to the rest. Okay, so the zones here are important because they're the basis for the distribution. So there is going to be, for instance, just recalling that picture, the Edu registrar administers the .edu zone. The University of Washington administers the Washington.edu zone, and the Computer Science and Engineering Department at UW administers the cs.washington.edu zone. All of these zones, or each of these zones, has a name server that hosts the information in the zone, and that's who you're going to contact for all of the information about the zone. If you want to find out about a computer inside cs.washington.edu, for instance, you would contact the CSE department's name server because it's going to know about it. Now for this to work, any zone needs to, so what's going on there? Any zone needs to include contacts for delegations. So the zone washington.edu, is going to need to include contact information for the cs.washington.edu, simply so that if you contact it looking for information in there, it has a forward pointer to say, well, I don't know what's inside cs.washington.edu, but I do know who you should contact to ask. Okay, so these zones are descriptions of portions of the namespace. But what does a description look like? What can be in it? Well, I'm glad you asked. A zone is comprised of a set of DNS resource records. And these resource records are the things that give information such as the IP address of hosts. There are different types of resource records. Each different type has a different purpose and it carries different kinds of information. Now the ones we might care about most easily or be familiar with is the A type of DNS record. The A stands for address, so an A record tells you, the value of an A record tells you the IPv4 address for a particular host name within a domain. Similarly, you might not be surprised to learn that there's an AAAA, it's pronounced Quad A record. That's the IPv6 address of a host. The Quad A name was chosen simply because the length of an IPv6 address is 4 times as long as an IPv4 address. And there are a few other names, types of record here. One of the most important is the name server record. This will tell you the name servers that this will provide contact information for the name servers for the domain. So it will tell you who they are and what their IP address is will be elsewhere in the file. Or it'll tell you the name server for a delegated subdomain. So this is how you can have a pointer in your zone to the subdomains which have been delegated. And there are various other records which are useful if you're running the DNS, but we don't need to worry about too much. I'll just briefly mention there's something called a CNAME, canonical name for aliases. So you can have multiple names for the one computer. You might have galar.cs.washington.edu might be a machine. The name www.cs.washington.edu might actually be the same IP address as Galar. They're just two different names. They're convenient. There are also different records if you want to find the mailers, the mail exchanges for a domain to deliver mail to a domain. And all zones start with an SOA, a start of authority record. It gives you key parameters about the zone, like how long the information is valid for, and who the name server responsible for the zone is, and so forth. Let's see a little bit of an example. Here it is. And we'll look at this example, and then this will conclude an introduction to the DNS, and then I'll dive later into how DNS servers use this information. So here is our nice zone file. Now it's interesting, this is written out in a textual form. Originally these files were written in a textual form, so we still have that sort of historical representation. This is the external representation that you and I can read. When this file is loaded into a DNS server, it could be in any representation, it doesn't matter. But this is a tabular kind of format that's fairly readable. So it starts just with a comment here saying this is the authoritative data, the real data for this zone or for this domain. And there are various records. Here's our start of authority domain. It's going to have some key parameters. But most things in it will then be things like the A address. Here are A records. They have the IPv4 addresses. Here was an NS record. It had the name of a name server. So star.cs.vu.nl is the name server for this domain. We can also find out, so the IP address for star is here, because here's the A record for star within cs.vu.nl. This other information is information such as the time to live or validity information. I forget what 86400 is. That might be the number of seconds in a day or something like that. And IN just means internet zone. And I think that I'll leave it at that for a DNS record. What I would like you to take away from this first part is simply that we have this that we have this hierarchical namespace for the DNS. We use the hierarchy to distribute it into zones. And each zone then has all of this information. What we're going to see next is how to use these different all of this different zone information to actually perform the translation in a distributed way. Okay, let's move on to that.